Hello, my name is Ali, and in this video I'm gonna show you how to make your own task manager for your Linux systems. So let's take a look at the final result at the first. In here I created some charts based on my desire and based on what I was curious to know about my Linux system. For instance, the amount of uptime of the system, the amount of used and available memory, the number of context switches between the various processes of the CPU, the number of forked processes generated by the kernel. In the CPU usage statistics, I defined a duration comparison between the CPU system usage processes, CPU user usage processes, and also the ones which CPU stopped for some I/O completion process to continue its work. In the memory statistics, we have a trend comparison between the memory cache size and the actual actively memory using, which the high level apps and services which I'm using right now is representing with a yellow line. In the process status, we have a chart for seeing the sum of sleeping processes, stopped, idle, and zombie process of the current session of the kernel. And lastly, in the this section, we have the comparison between the amount of free and used hard disk and a dashboard which indicates that how much file is reading and writing right now, which in the last step of this video I'm going to recreate this dashboard to get familiar with this platform. So the first question which might cross your mind right now is that what the heck is this platform? I'm gonna answer that with one URL which is here. It's called Grafana. Grafana is a visualization platform. Is somehow is like ELK, Kibana, Apache Kibana, but this is the little version of it, suitable for small and rather medium scale projects to represent and monitor the log files and make some visualization based on their requirement. So for this project, the first thing we should configure and install is that the Grafana itself. Installing Grafana, it's easy as a pie. You can install it without any hassle, and it's provided for various OSs. Since that my computer is a Debian based, I installed this, and with the package you can easily install and run Grafana as a service. But the main thing which you should check it after installation is the configuration file of it, which is here. etc Grafana and Grafana itself. It has a configuration file for configuring, for example, the protocol which Grafana uses to represent the platform and the default port of it, HTTP exposing, and so many other configurations which would be handy whenever you want to customize the Grafana for your organization. So take a look at this. After installing the Grafana itself, the next thing which we need to install is InfluxDB. InfluxDB is a very powerful database for time series data. Let's take a look at the benchmarks. For example, the comparison between the InfluxDB and Apache Cassandra. Higher is better, you see. Lower is better, you see. comparison between the MongoDB and InfluxDB. Trust me, it's very powerful in a situation in which you are interacting with the time series data. For instance, the log files of for example, a huge platform. InfluxDB can help you in these situations. For instance, higher is better, and so on. Configuring and installing InfluxDB, same as the Grafana, it's easy and it has supports for macOS and Windows machines also. You can download it and install it using the package. It's easy. The next thing which we need is Telegraf. Telegraf is a data collector agent which collects data from the performance metrics of the Linux system and store it into InfluxDB. So the installation is the same. After installation of Grafana, InfluxDB, and the Telegraf, we can check that they are running properly or not. And since that I'm more convenient with the systemctl, I will check the systemctl status list unit files hold grep, sorry for the typo. As you can see, Grafana is running, Influx database service and InfluxDB service is running, and Telegraf is running also. So we can check the database itself. As you can see, it creates some database. Telegraf, it creates some database into InfluxDB. And this is the metrics, this is the KPIs which Telegraf stores into InfluxDB, and we are going to create some dashboard and create a monitoring system for it using the Grafana. So let's recreate the dashboard related to the disk management. By clicking on this, we can create some new visualization. And one thing I forgot to mention, after you install the three components, you install Grafana, you install InfluxDB, and the Telegraf, you should add the InfluxDB database as a data source in here in the Grafana, so you can create some visualization based on that database. By clicking on this, data sources, click discard, you can add data sources. It has support for many data sources, many databases, such as Google Stack Driver, supporting for Amazon AWS, and so many other databases which you can find online. By clicking on InfluxDB and your default HTTP URL which you configured in the InfluxDB, and choosing some name, everything should be good and you can access to your InfluxDB database. It's okay. So let's get back to our visualization and create some figure, create some chart. Click on add the query, and in the query section we defining the database which we are using for creating visualization here. On clicking select measurements, I'm clicking the disk IO, and which column I would rather choose read bytes, and as you can see, since it's bytes, we should divide it by 1024, which I'm doing that with mass method of it. And by clicking this, making it linear, we can name it amount of read bytes. By clicking the query inspector, we can check the actual query, which is queried by the InfluxDB. We can add one more measurement, which stands for write bytes. As I'm lazy, write bytes. We can choose color for it, proper color for it. For instance, green. In the next section, you can choose what kind of visualization you need for your measurement for your KPI which you are representing, which the simple graph is suitable for me. You can make it prettier, make it gradient, and so many other things which you can play with it in order to make it more accurate and more representative. As you can see, we can change it as a table, and one good feature is that representing the average of it or the minimum value of the measurements based on the history which it has. For example, I'm choosing the average. The average number of reading and writing byte is also representing here, which is good. Here I will write the name of the chart, the name of the figure, and as you can see, we can create some alert which indicates that, for example, whenever number of some measurements goes above something or goes below something, we can notify it about that. And that's it. We created some dashboard just like this, the before. Resizing it is quite tricky here. We can see the granularity, how often the data refresh here. I'm choosing here this, and we can check that, for example, the last 15 minutes visualization. We can make some annotations in the figure itself. And a very useful feature of Grafana is that you can share one dashboard with iframe. For example, you have your own web service and web portal, and you want to embed this into your own web service, and you can do it easily, but it needs some configuration. It's called anonymous access, which you can configure it in the configuration file of the Grafana itself. It's easy. Or you can simply create some link for users, which you can add here. Discard for you can add users and create some account for them, and they can see the visualizations or the monitoring system by logging in into Grafana service. So this is the final thing. Hope that you enjoyed it, and have a nice day.